Open, okay? The mics are coming up now. Can you hear me? All right, everybody. Here we go. Stand by. We got a great show for you today. Thank you for joining us. Speakeasy Americas is Studio 3 in Naperville, Illinois. Now to introduce your host for today on the technical training team, Mr. Tim Morgan.
Welcome. Good afternoon. That last episode was pretty good. It's always a treat for you to have.
He's always a good time.
Yeah, it's hard to describe. He's always a good time.
Like the Energizer bunny that just keeps going and going and going. He's never stops.
Exactly. So what we're doing here this afternoon is we're going to be going out into Studio 1 with the guys out the studio out there, and we're going to talk about blueprinting, measuring, and repairing. And it's amazing when you sit down and you put the numbers together, how the shops are really looking at their business and how much of their business is really driving motor vehicles considered to train wrecks. But good afternoon, gentlemen out there. How are you doing? You look like you're well rested and ready to go. Okay, you got your power naps in and everything.
Oh, ouch! I think there's a story behind that one, isn't there, Tim?
Yeah, there might be a story behind that. But when you start at 3 a.m. in the morning, it's understandable that mid-afternoon, you talk to that. All right, so why don't we get right into it and we'll go to the presentation here and start with this presentation, and then we'll add in some actual live demonstrations.
This is the point where I run over and say, it's not a presentation mode.
It is a presentation.
It's not here. Hold on just a second here. I'm going to go back to camera 1 and do that behind the scenes stuff, scrambling underneath tests and everything. So bear with me.
Okay.
Tim, can you?
Yeah, I can entertain for a minute.
All right, perfect.
Yeah, it's pretty good. It's been a pretty good day so far. I can back with very benign first this morning, which was very good. And then really sharp, 12:30. And something around now we can go live for the next hour. I'm talking about blueprinting, measuring, and repairing. I don't know if on the shop management side, if you actually look at the full detail of everything that's out there, what's coming in your facility, what's the car count, what's the car count in the market area, by make and model, you know what you're going to be preparing. We do know we've already discussed that it is getting harder to get parts because of some shortages that are out there. So when we start to look at those shortages in parts, we end up with extending the length of our rental, and beyond extending the length of the rental, we're at a point where our customer's out of their car longer. And that's a big factor. So let's get right into this presentation.
There we go. Here we go.
One of the first things I always like to come up with a quote now and then the competitor is to be feared is the one who never bothers about you at all, but goes on making his own business better all the time. And this from Henry Ford, and you can tell that Henry Ford has done that through his life, and now third generation and fourth generation coming up to run Ford Motor Company and understand what they're doing. The key there is, I never worry about what my competitors are doing. I'm always worried about what we can do next and better and move forward. The business itself is not the same as it was. And you look at the gas prices here, don't we wish we would have these prices today? This was way before I started that one, but if you start to look at your collision repair business, if you're operating it the same way it was operated for the past 30 years, you're missing a lot of things that we could be putting on your repair plan. You can be occupying your times better, knowing exactly what we need to do up front with the repair when we talk about blueprinting. Let's take a look at some key KPIs here. And the first one is the national length of rental. And I'll have you know, new information came out today from Enterprise. This number, since we put this presentation together last week, has jumped now from 13.2 to over 15 days in a rental. And again, I'm taking the keys to that being that they're waiting for parts. And the parts are not always available. So then if we look at the average repair cost, we're looking at $3,527. We look at the percentage of non-drive vehicles, we're at 22.7%. And at 22.7%, that tells me that 70%, 77% of the vehicles that I'm repairing in my facility are drive-ins. And those drive-ins really need to be able to be facilitated quickly. And by facilitating it quickly, I mean making sure that we do a meticulous disassembly of the vehicle. Finding out what fasteners we're going to need to have to replace right away. We want to find out. Even some facilities are actually even taking the paint coat from the car and beginning color match at that point so that they're ready when those parts are available. And their goal is to be able to have all the parts when that vehicle is put in the process. We want to be able to order all the parts up front. So look at the parts part of the business, and the total part of the parts is 40%. The labor costs are 39%. Average hour of the repair claim is 24.4. The average buy labor rate across the country averages out to $52.50. But look at the touch time here at the bottom, 1.8. And obviously now that top line is going to go up 2 more days, that's going to take that 1.8 and drop it down even further.
And that's 1.8 hours per day.
1.8 hours per day. So that's why it's taking so long to get somebody back out of their van.
Goodness, that's a horrific number for efficiency, because you're talking about, what's the technician doing the other 6 hours?
Well, I mean, he's obviously probably working on new cars. But the key factor here is if we have 77.3 vehicles in our facility that are drivable, that means that our repairs are not as large as they maybe used to be. We're not doing the heavy hits that we used to be doing. So we need to be more efficient in how we're doing our repairs and our repair planning. So when we look at a business focus and we're trying to focus on our business, there's key points that we have to look at. We have to look at our profits, obviously. We have to negotiate better, not just negotiate with the insurance company better, but the rest of our business partners to make sure that we have the right buying power for our parts, the right buying power for our materials. And we also have to make sure that we improve our close rate on those estimates or the repair plan to make sure that we're going to have a safe, proper repair, number one, and also that we've got that customer committed to us to allow us to do the repair. At the same time we're doing all this, our employee satisfaction is going to improve because now we're finding more what has to be done in the car, and it's not the back and forth between the back shop and the front office and having to go back and write multiple supplements and find multiple parts that were missing from the original estimate. So we're going to also improve our employee engagement. At the same time, we are improve our speed. It's going to improve our customer experience, our accuracy of our repair process is going to be improved. So all of that is going to improve our bottom line. And by doing a better job in the repair planning process, especially by adding maintenance, because it's our indication, we actually own our own body shop in Italy that runs full time as a standalone business. We find there, and what we also find here at Spinizzi Americas when we're out working with our business partners and the rest of the Spinizzi family is that by measuring the vehicle in a blueprinting process, we can turn around and find more damage up front that otherwise would have been noted, which would slow down the repair process or actually maybe even interrupt the repair process until some parts can be obtained. And then we add in all the different technologies today when we add in collision avoidance or your ADAS, which we're going to have a presentation coming up tomorrow on, I believe it is on ADAS. You start to look at cars. We've seen this morning with Jerry Benani, some of the things that they're adding into the vehicles, adaptive cruise control, lane departure, autonomous driving, adaptive headlights, Bluetooth technology, and something that was new to me this morning with Jerry Benani, that your phone is your key. No longer needing a key fob to be able to start your vehicle and drive the vehicle.
Now that is, we knew NFC was coming in, which is near field communication with your chips, and you're using it in your Apple devices now. But for a major OEM to incorporate that into the vehicles, that is truly something that's going to be, you're going to see that a lot more in this industry.
Well, I use my mobile phone constantly to be able to start my vehicle instead of walking to the keypad. Because obviously from the time I get up to the time I go to bed, the phone's in my hand, and everybody fortunately knows that because I'm always communicating. But I mean, to see it be able to, it's now going to start and drive the car. That's pretty exciting. We look at the 4 things you need to have a proper repair. We're looking at, you have to have obviously the knowledge. You need access to the OEM information. And that access to the OEM information, that needs to happen in that blueprinting process. We need to know what procedures are out there and maybe what's not out there, so that we can make sure that we're repairing the car correctly. We see it again this morning. On that Bronco, there were several different repair procedures to be able to section the frame, both front and rear, on that Bronco. So that's pretty exciting stuff. We have to have the proper skills. And we also have to look at, we have the proper tools, the proper equipment, and the proper supplies to be able to continue to be able to do it.
And that's a critical question for every shop owner. If you're not asking the 4 pillars questions every day, Do you have the right everything in place? You know you're not going to be successful. You can't be.
No, you're exactly correct, Paul. It's a big struggle in the shops every day, and I know from previous shop ownership and shop management on my own, really back in the 80s, talking about all that. Even then it was a struggle. And we didn't have the technology then that we have today, and things at our fingertips that we have today to be able to facilitate these types of repairs.
Well, in your next position in your shop is not going to be a body fit. In my humble opinion, that your next position you could be hiring for is going to be electronics guy. Your ADAS, your calibrations. Somebody's going to be able to work on these electrical systems in these vehicles. They're just so in depth at this point.
Yeah, I think you're correct there. I think that it's going to open up a new placeholder, if you want, for a technician in the facility to be able to be that person that does those calibrations, does those scans, and does the high-end electronics. But that's basically what we have, and we have that in every. When we're looking at the typical collision repair process, if I click to the next slide, we can see that typically in the shop, they're going to write the estimate, they're going to order the parts, maybe an insurance appraisal at that point. Post-COVID, though, we know that a lot of those are just being done by an audit via the internet or the phone from the pictures that we take. Then the vehicle is going to be disassembled, pre-inspected, supplement at that point. That's what we want to stop, is that supplement right there at that point. We want to measure the vehicle so that we can make sure that that surprise, once I get that vehicle dismantled, is a surprise earlier on, so that we can make sure that we have the proper repair plan. We may need to, because of measuring the vehicle, now we know we have to direct that to even which technician in the facility. Does it need to go to an A-tech that's going to be able to do the frame or structural repair part, or can it be your C-tech be able to handle that repair? So it's also going to dictate where does the vehicle go in our facility. It takes you back to thinking about how we do this. We do it through process and procedure, just like McDonald's does. Setting up your facility for being able to do things properly would be making sure that we have the correct tools in the correct area so that we can be efficient to be able to facilitate that repair or that dismantling the same every time. As Louis mentioned in the earlier segment, that one of his own employees came and said, hey, we can streamline this blueprinting a little bit more if we do X, Y, Z. It should always be an evolving process that you could add or take away something in that particular situation when you're blueprinting to be able to facilitate it better. When you look at that, also, I'm looking at that amount of time is going to help me gain time on the other end and get my customer to feel back faster.
And that's really the goal. The efficiency is the goal.
Well, and you start to look at the number of vehicles that have no supplements is only about 26.6%. One supplement, over 58% of the vehicles coming through the facility. Two supplements is about 14.3%. When I see here someone having 4 or more supplements, it's just unimaginable in my business. I just couldn't see that. Typically, doing the proper disassembly, doing the proper measuring at that point in your first parts order, I could possibly see on a drivable vehicle that, yes, you may have one supplement and you find something extra. But one of the other things that you could do in the blueprinting process would be able to add in suspension checks, because that's where we see, from the strength of our tools and how we're operating, that's where we see that, oh, wow, this is spent. We didn't know that was spent. Now we gotta go and we gotta replace that suspension part. So why not check those things up front to be able to add that to the quality of my blueprinting, so I know up front, hey, I'm gonna need a tie rod for this car, or I'm gonna need a strut, control arms.
Well, and how do you know that your ADAS systems are going to work properly if you haven't measured the vehicle in a pre-diagnostic before you even go into the process? I mean, that's really the question I'm asking.
Okay, when you look at the ADAS, it's out the window right at this moment. When we talk to Frank tomorrow, you're gonna see that from the statistics that he's been able to gather, only 16% of the shops today are even dealing with ADAS, and it's less than that are even putting it on an estimate and getting paid for it.
That's shocking. That's absolutely shocking.
It's very shocking, and I think it's a change that needs to happen. All that stuff needs to be caught sooner so that we can make sure that it's taken care of.
Yeah, absolutely.
So we're going to add measuring into the mix so that we can reduce the actual repair time overall when we start to look at from start to finish. So when we look at process goals, as I said, when I look at a drivable vehicle, I'm looking at one supplement, maybe 2 parts orders. And when I'm looking at those 2 parts orders, I'm going to have an on-time delivery. But if I can get that drivable vehicle and have the information up front, I should be able to put this process goal in place in my facility. Now, when we're looking at non-drivable vehicles, we have a better story there. If I have a non-drivable vehicle, I should have 0 supplements because I'm going to do a complete blueprint of this vehicle. I'm going to know right down to every nut and bolt because I have the procedures from the OEM of what really needs to be replaced. I'm going to do 1 parts order for sure, and will still be able to promise my customer and deliver to my customer on time because I've done the homework. I've done the blueprinting. I've searched out every part. I know when my parts are available, so that we can make sure that we're promising the customer that we're promising it to them on time.
But does that fall into the we don't have time bucket in order to do that kind of meticulous disassembly?
Now, I've heard that before where someone says, I don't have time to do that. If I'm shortening your repair process, if I'm making your customer's experience better, if I'm improving your CSI, if I'm improving your employee satisfaction for their job, I think it's a win-win. And when you talk about adding the measuring solution into this process, it's just a no-brainer because I'm going to spend 15, 20 minutes of extra time, if you want to call it, but I just found 5, 6 more hours of repair time, which is labor.
Well, that's like tripping over pennies tripping over dollars to pick up pennies.
Exactly, and that's just on the structural side of it because we find on even drivable vehicles where an upper apron is out of place, a core support is out of place, and in those positions, if I was just to order parts and start fitting parts, I now got to back up and I have to do some structural work. Not to mention, if I'm going to have to mount the vehicle to be able to do that structural work, now I'm also adding time and materials for the paint part. Because now I'm going to have to go back to where I anchored the vehicle. I'm going to need to sand, prime, paint. So I have materials added there. Maybe there's some sound bender or something that has to go back in. There's just so many things there that we have to look at. So when we look at measuring for repair planning, it could be as simple as just pulling the vehicle in your front door with a dedicated estimating bay, measuring it right on the shop floor, measuring with a twin post lift, or on a rack or a bench. You look at our multi-bench, for instance, our multi-bench really is a quick pull the vehicle on, take it up, and be able to measure it without a large process. Just simply drive it out. The next thing that I hear is, well, when do I really need to measure? You need to measure 3 times. We need to measure before the repairs, we need to measure during the repairs, and we need to have a post-repair measurement so that we have reports that are going to go in the files for all 3 of these times that it was measured. And the other thing you have to take a look at when you look at measuring is the P pages that you find in that everybody's referred to for years is really only talking about measuring the lower side of the vehicle. So if you're doing under hood measuring or something like that, you're going to find that when I'm measuring underneath the hood, I'm measuring door openings and all that. That's an extra labor operation that needs to be considered. So we're going to have to make sure that we are documenting all that so that we can make sure that we can get paid.
Well, that reminds me that we have Denny Grimberg, plug for Friday, plug alert, noon Central Time, talking about DEG and included, non-included operations. So this will tie right back into that.
Yeah, absolutely. So what I'd like to do now is if we go back up to Studio One, and we get with the guys out there to be able to do an under hood demonstration and just show how quickly that you can be able to go and measure the vehicle.
All right. Well, let's go out there. Let's see if they're awake still.
Take it away, guys.
And does evens odds matter as you're doing this, Jeremy?
Then this front fender bolt.
I see now that we're getting self-recognition, Jeremy.
Yeah, so you can see automatically now the machine's starting to learn where it's at. That thud noise is it's telling you you're near a measuring point. So when you're within 50 millimeters, it starts to realize that you're close to a point. So our second point here, we'll measure right in the center. Walk to the other side of the car and get 0.7. And then 0.17 back here, the front hood hinge bolt.
Now, Jeremy, if the vehicle was hit on one of those sides, do I have to start with 4 points?
No, you don't. You could actually start with 3 points. You could do a 3-point free alignment, and you could maybe leave out this left front corner area and not align with any of those points. We could concentrate on the points that are close to the cowl, and then also include some points on the other side that are still good. And what you can also do is you could start making some pulls and get the structure closer, and then you'll notice that once you start aligning everything back to where it needs to be, then you can start getting some more alignment points and using those. So the alignment was good. If it was not good, it would have given us an audible alert. So what we can do now is we can go right into starting to measure the points. I'm going to run right down the fender rail, and you can hear the self-recognition.
So with that self-recognition, you're not at all tied to that computer. You're just measuring from point to point, working your way around the car pretty quickly.
Right. Yep. As soon as you're near a point, it's going to tell you. So we're measuring a stamped hole right now. And when you're measuring a hole, you actually take 3 measurements on the edge of the hole, and it finds the center automatically. So we're going to move on to this fender bolt. So just like that, we've measured the entire under hood of the vehicle. Now, you notice that one of those points turned red, and that meant that it had some damage there. So what we'll do is I'll show you how we can use the follow the pull attachment. The follow the pull attachment actually is designed for live measuring while you're pulling. So once again, let me show you this point. There we go. So that point is actually not within specification now. So we'll install the follow the pull attachment. And it's actually magnetic. And right here, we'll click the follow the pull. And you can see here that it tells you exactly which way you need to go. You need to go basically pull that point 4 millimeters outward or positive width. So you can see where that would be very helpful if you had live measurements.
Well, it'd also be very helpful if you had a young technician that didn't realize, or have a lot of experience with pulling, because as they start to pull, they're going to actually see the direction and make sure that that number is decreasing. If it starts to increase on, one of 3 of those axes, length, width, or height, they can readjust their pull.
Right. And what's also nice about that feature is when you make a bad point or you find damage, the arrow there on the screen it's telling you which way you need to make the adjustment. So you can actually print a report that tells you that it needs to be corrected in that direction. So that's really easy to hand over to the insurance or whoever's paying to repair the car. So you can see that it's literally took us
Didn't take very long. You went through that really quick.
a minute, 2 minutes to measure the entire underhood. So
Well, and you're taking your time explaining it and demonstrating it. Just think if you were a technician and you were just under the hood to be able to collect the information, you're going to move a lot faster. But you can see you've collected, looks like 10 points of information in just that couple of minutes.
yep, super easy.
And now I know exactly that. Where does this thing need to go in my repair process? Do I need to move over to a structural stall to be able to, make a quick pull on that? Does it need to go on a frame machine? Where do I move to next? And it's not just for underhood. We also have the ability to be able to measure door openings. We have the ability to be able to do trunk openings, window openings, striker edges, wherever you need to go to be able to measure the vehicle. Besides our data that we use, that's three-dimensional data, we also have the ability to be able to use that tool as a tram gauge. And be able to use our Mitchell data. We can create our own data by adding data points. As we see on some of the vehicles today, when you're turning around and you're looking at the ADAS connecting points on the vehicle, you may find that there's no data from the vehicle manufacturer. So you may have to go to the opposite side of the vehicle and create what we call a mirror point, where we're going to turn around and we're going to make a mirrored image of the undamaged side, and then go over to the damaged side of the vehicle and be able to create that point, or be able to put that point back in position.
So Tim, if I'm doing a mirror point, I got two questions for you here. Number one is, do I have to use a point that is already in the data sheet, or can I use just any point on the vehicle? Number two, can I save that information for later?
No, you can make your own data. So, you're saving it for any time you bring in that make, model vehicle. You're actually adding to the database. You can even include a photograph of those mirror points, or those images that you create of measuring points, and you can create your own up to about 50 points of your own data, besides what we supply. And amazing thing right now is we can supply infinite amount of points. There are certain vehicles out there today that we have over 250 measuring points for, to be able to make sure that every spot on that vehicle that may have a procedure or may have a need for a measuring point actually is there and in the database.
Well, that's got to be a vehicle with some tight tolerances. But you know what? More data is better in my world. Absolutely.
Well, and again, you look back to the repair procedures that are out there today, they're not getting any easier. So we need to make sure that we're supplying data on our end, that we're, gathering the information from blueprints from the vehicle manufacturer. We're consulting with them on what are their repair procedures going to be on the car, to make sure that we're facilitating that we have not just universal fixture information, but touch data information to be able to hold those points and measure those points. And from there, not just upper body, but the underbody, and the complete vehicle.
Oh, well, I should say that those, that you said 250 points on a vehicle, that's a tight tolerance vehicle. But, the fact of the matter is your tolerances are tight on almost every vehicle coming off the assembly line today. I mean, pickup trucks used to be plus or minus a foot and a half, for panel gaps, and they're not like that anymore,
No, I mean, I think that we'd probably have to consult with ICAR and the OEMs to figure out where we're at with the plus or minus theory anymore. But pretty much on the bottom side of the car, you're going to be plus or minus 3. And some manufacturers, as you said, one of the manufacturers that we know we have 250 points or more, their tolerances are less than that. And I can tell you, working with a different manufacturer, when we have to validate our data sheets before we even physically ever put them on a vehicle, I've seen tolerances between our data, the OEM data, being, 0.2, of a millimeter. That's just, wow. 1/4 of a millimeter. Who would have thought of it?
That's very small margin of error.
Well, when you're working in a CAD world, that's what you end up with. And we actually, in a CAD world, can take our frame benches, put our fixtures in place, and then drop their CAD on top of the vehicle, and make sure our fit and everything is there. And it's a pretty amazing process. If you've ever seen it happen, you can remove washers, you can remove the fixture. There's all kinds of things that you can do virtually before you even touch the car.
Wow, it's amazing. Well, what's going on now? What do we have?
The next thing we want to talk about is suspension parts itself. And we look at suspension parts. This is also a big bottleneck. I like years ago, it used to be $445 on a Friday and it's going for a wheel alignment, and now we're paying for a rental for the weekend. But in all reality, that doesn't have to happen. And plus, we're not delivering vehicles on a Friday anymore. We're delivering vehicles every day of the week if we're running our shop at a good modern process.
Well, that's what we hope, at least.
Right, exactly. So we want to be able to measure suspension parts, to be able to compare it to the undamaged side. Also, if for some reason I had to use a like kind quality part, that may have been a suggestion from an insurance carrier standpoint, or even a customer pay standpoint from a customer, I now can verify that part before I put it in the vehicle by actually measuring it. So I can measure as you see there, I'm measuring a control arm from point to point, connecting positions to be able to check the distance and then go over to the car. This can be done in the car or out of the car. You look at control arms, being able to measure key points on a control arm to be able to make sure that there's no bend. As you see in that particular slide there, all we're going to do is do a distance between 2 points. And we could also do a two-surface angle to be able to make sure that 3D wise that the part is good enough to use in the vehicle. Or if it's still on the vehicle, to measure undamaged side to damaged side to say, hey, this is the part we have to, replace. Wheel hubs, same thing. You're going to be able to use a two-surface angle to be able to measure and diagnose what you actually have before it goes on the vehicle, or again, before I take it off the vehicle. For years, the process was, okay, we have suspension damage, so I'm going to turn around and I'm going to put a strut in it. And then I find out it's not the strut, so I go ahead and I throw a control arm in it, and then the last thing I do is throw a knuckle in it. Instead of diagnosing individually every part up front, as we can do with our touch system, and then turn around and know, pinpoint, that's the part that needs to be replaced. Saving time because I'm only replacing one part. I'm not ordering a whole bunch of other things, having to send things back. And my repair process is moving along again faster. And the same thing with a strut itself, using a straight line angle. And what I mean by a straight line angle is we're going to draw an imaginary line straight through that strut. So from the top shaft there that you see where that technician's pointed, all the way to the bottom of that strut connection, we're going to measure 3 points around that shaft in 4 different positions down that strut. It's going to draw an imaginary line through it. And if it's out of spec and it's not 0, that tells me it's bent. We can do that on a twin post lift. We can, as I said, in the vehicle, out of the vehicle, so that we're having an efficient repair. So what I'd like to do now is let's go back out to Studio One and our gentlemen out there that are set up to be able to show us how to be able to do some suspension measuring.
There we go.
All right. First, we're going to start out. We're going to do a quick two-surface measurement. Essentially, what the touch is allowing us to do, we create a plane on the wheel, and then we create a plane on the floor, and it'll tell us the angle for that. It's a real quick, easy diagnostics tool to maybe catch a bad camber or something, so you know that you need to dig further into that problem, further diag the issue, maybe find that bent strut, knuckle, whatever suspension part may be bent up front. So we're not trying to deliver that on a Friday and it comes back from the alignment shop. I'll run through that real quick. I come down, measure 3 points on the wheel, and I'm making a triangle. And then I just come over here to the floor. Three more measurements in the triangle.
So basically what you've done right there is you've just made a camber plane by taking 3 points off the floor and then 3 points off the side of the wheel.
That's correct. And did you see on the screen? We got a 90.
Okay, so we know that that side of the suspension is within the tolerance. So now we just need to go to the other side and then we compare.
It's real simple. I don't have to change anything on the machine. I slipped on that one. On that one, we got an 88.9.
Well, you're within 1 degree from side to side. So you, at that point, you need to look at what's the specification from the manufacturer. And we do know that when we took the original upper body measurements on that side, there was a point out at the actual strut tower. So that could be that camber problem reaching all the way back to the measurements that were taken originally when Jeremy measured it, showing that strut tower was not in the right position.
That's correct.
So pretty quickly, right there, you were able to quickly diagnose what you have for camber in just a matter of seconds.
You bet. And I can also quickly just check the toe on this real quick by measuring distance between 2 points on the back of the tires. Then go over to the other side. We have a distance of 1891. Now we'll check the distance of the front.
One caution for you technicians that are out there, make sure your steering wheel straight when you perform these tests.
So we're in 1899. We do have a little bit of a toe out on this.
Well, again, if we go back to that vehicle was originally hit there on the right front. We know that there's a little damage in that strut tower, so that all sounds correct to me of what you're showing.
I'm going to go ahead and remove our extension. And change our probe. We're going to do a quick demonstration on the two straight line angle. This allows us to measure a strut, axle, rear axle housing, anything like that. Kind of see if the cylinder's bent.
Where that would come really handy on a rear axle would be measuring the outside near your outer edge of your axle, and working your way in towards the pumpkin, and then the other side of the pumpkin or center carrier, and then out to the backing plate on the opposite side. And it should be 0 if it's straight. If it's out in degrees, that means that axle housing is bent. Same thing that you're doing right there with the strut.
That's correct, Tim. And I can speak from personal experience of a guy that we put in a used rear axle housing just to figure out that the used part we bought was bent. So it's also good if you get in that situation to maybe check your part before you put it in the vehicle. So we got a 4.6 degree.
I'd say she's bent.
And of course, the strut, you can visibly see it does have damage and is bent. We could also use the touch, which I'd have to move the probe, as you had pictures up, to measure distance on A-arms. Have to move the table closer.
Now, all these checks that you're taking here right now, these could be added to an estimate as suspension checks.
Correct.
So this is basically allowing you to do suspension checks before you would do a pre-wheel alignment or a wheel alignment, which in effect is really going to save the technician in the long run, because I'm going to find all this stuff way ahead of the game when it comes to the actual repair.
Exactly. And it'll also allow you to document the damage. You're measuring like an A-arm, and we could either go to the undamaged side. Maybe we already have the new part. You can measure the distances from holes. You can change it to do a 3-point measurement on a hole. That way you're measuring center of hole to center of hole. And you can do comparative measurements, show that it's bent, it's shorter on one side, longer on the other, and document it all and have a nice printout for the insurance company. That way you can get yourself paid.
That's pretty amazing. That just goes and shows me why it's called a touch, because whatever I could touch, I can measure. And as you can see there, you're not even on the car.
No. All you really need is a stable cabinet, and you can measure pretty much anything you want.
That's awesome, guys. That really takes the blueprinting process to the next level, and not just the blueprinting process, but I think the complete repair. Because if for some reason the vehicle gets past the structure, and all of a sudden we find that we do our suspension checks, we're going to be able to upfront be able to grab those parts and get them replaced before the car goes out for the wheel alignment, because we know a majority of shops are not doing their own wheel alignment. They're sending it out, and they're only getting paid once from the insurance company for the wheel alignment. So if they're having to send it out to find something's bent, to bring it back and diagnose it, you end up with a large amount of downtime. Not to mention your people out of your facility, because the last time I checked, if you had to drive a car to a suspension shop, you're going to turn around, and that's 2 people that have to leave the building because somebody has to pick them up. So even if it's the person, the guy or the gal who's sweeping the floor, I'm not gaining any productivity out of these 2 people that are shuffling these cars. And not only does it go there once, it has to come back, get repaired, and then go back again. So those technicians are, like I said, even if it's the floor sweeper, it's the estimator, or the owner has left that building, say, at least 15 minutes each way. That's an hour and a half of valuable production time for the people that have left the building that's being lost.
Oh, absolutely. And we're talking about efficiency here and making sure that we're getting paid for what we're doing. And you're spending time shuffling cars back and forth, and I don't know how much you get paid for that, but I'm sure it's not worth it, is it?
Well, I don't think you're getting paid at all most of the time.
That's the problem, is it's not worth it. You're paying to have it done. You're
Right.
not getting paid for it.
Exactly, 100%, 100%. And our basic goal is to make sure that we have an efficient repair, an efficient facility to be able to make the repairs in. So I think one of the last things is be prepared for the future direction. What that is, it's changing every day. I want to thank the gentlemen out in Studio One for their great demonstrations this afternoon. And I want to remind you about day 3 tomorrow. We start out our session tomorrow at 10 a.m. Central Time with a new ADIS information, knowledge, and repair procedure platform presented in our technical series by Mr. Frank Turlip, a good friend of ours. And then at 12:30 Central, we'll also have another good friend of the Spinese family and part of the Spinese family, Clay Holbright, the owner of Best Body Shop, talk about some of the things that's been going on in his business for the past 18 to 24 months in the direction that he's taken. And then at 2 p.m. Central, we have a hiring the next generation of technicians. And I said this in a previous presentation, the Zillennials are coming. I didn't hear that until of a Zillennial until last week. It's going to be pretty interesting to see what they can bring forth in that roundtable with Mr. Doug Irish, Mr. Corey Millar, and Ms. Amber Ritter. Amber is from the Collision Repair Education Foundation, and we all know that Doug is from Fayetteville College, and Corey's working in placement of employees in other industries. So it should be pretty interesting day tomorrow. I don't know. What do you think, Carl? What else you got to add?
Well, I know that I know that we're bringing in the enemy, and I don't want to talk bad about Corey, but I've already told him, I said, you're going to be the enemy in this one because he's a recruiter for high tech firms, and I've asked him to kind of come in and share what they're doing to recruit people, because I think that we need that kind of information in this industry, because we're competing against that group of people, which is the tech industry and so on. To recruit people that have grown up on computers with phones in their hands.
Well, it's cute. It's cool. I mean, can I get a job where I can play games all day?
Don't ask me. You should see what's in front of me right now.
I mean, you're over there pushing some buttons over there, not me. So I don't know anything about the technical side. I just gotta. Is this on? Is this on? Oh, and what's coming in this ear here? You got all the technology over there.
It's fun to play with the buttons. It's only when it's good, though. When it's bad, it's a whole nother thing. But anyway, we're gonna have great sessions tomorrow. Don't forget time change and addition to our surprise. DEG's in the house tomorrow or on Friday at 12 noon. 12 noon Central, 10 a.m. Pacific, and Danny's going to be going over some great stuff. That's our surprise guest on Friday, so don't want to miss that. And we also Thursday have confirmed Rivian, the electric adventure vehicle company, going to be on with us live to talk about their new collision repair program. Their vehicles are launched. They're out on the road. That's going to be pretty exciting. We also have Ian Morton, the owner of Fix Auto Thoroughbred and Fix Auto Sierra Vista, to talk about his transition in business. And he's a wealth of knowledge from the positions that he's held over the years, and to see how his business has grown. And then we're also going to do a segment on straightening small, medium, and large damage vehicles on Thursday. Friday morning, we also have welding and joining. So we're going to be talking about some welding. We got a lot of stuff yet, action-packed, that we still have to get through. It's only Tuesday afternoon. It is only Tuesday afternoon. It feels like we've done a lot already. So I'm actually pretty happy with a lot of the content that we've delivered so far. So I hope you are as well. And you don't want to miss what's happening the rest of the week. That's for sure.
Well, and I have to tell you too, Carl, you've been working really hard over there, pressing all those buttons, making sure all the wires are connected correctly and everything. And it's not just that we've been on the air 2 days. We've spent more than 2 months prepping for this week. it's pretty amazing what we've been able to put together. And I gotta thank everyone here in the building, because I know they're all probably sitting at their desks watching us live. Also, every person in our company, including people in Italy, have been involved in trying to put this together. And it's pretty powerful to be able to have the first Spineezy Interactive Week. Not to mention that we're going to launch this platform on a monthly basis from here on out.
Well, and we're gonna need some more zip ties. That's all I'm gonna say.
All right, Carl, take us out.
All right, everybody. Hey, thanks so much for coming. We're gonna have a great rest of the week. So stick around and come back for more. Thank you.
Collision repair education for education program. To create qualified entry-level employees ready for career opportunities are in. Can't do this mission without you. Each year, the foundation works to connect corporations, individuals, to schools, and students across this country. By being a part of our mission, you become an amplified force of reaching students, instructors, and community businesses in every corner of industry. From where we stand, together, we see our community evolving and supporting each other. We see connections being forged, fostered, trust. Connections that live long past graduation day. Connections that form the foundation of our workforce and shape the future of collision repair. For support not only provides the much-needed resources for instructional education, for local communities by facilitating a sustainable workforce trained and positioned with for the future. Learn more about how you can impact the collision repair industry yesterday, today, and tomorrow.